We are solving numerical problem related to the heat equation, or we can say related to the specific heat capacity. This is one of the numerical problem. Look at this. An iron ball of 4 kg mass is cooled from 20 degrees Celsius to 10 degrees Celsius. How much amount of heat is released? How much amount of heat released? Specific heat capacity of iron is given as 460 joule per kg degree Celsius. Before solving the numerical problem, it will be better to write the information given in the numerical problem. What is given first? Mass is given and its symbol is m. This is 4 kilogram, and then there are two temperatures. One is 20 degrees Celsius, another is 10 degrees Celsius, and 20 degrees Celsius is initial temperature. We can write initial temperature can be represented by T1, and this is equal to 20 degrees Celsius, and another one is final temperature. Final temperature can be denoted by T2, and this is how much? 10 degrees Celsius. Now another information is also given. What is it? Specific heat capacity. So I'm writing specific heat capacity, and a symbol is S, and this is 460 joule per kg degree Celsius. Now this is a very simple numerical problem. And what is the question? Question: how much amount of heat is released? Heat released. Heat released, or we can say quantity of heat, Q is equal to what? Now this very simple numerical problem, we can write the equation and directly we can solve the numerical problem, or we can go through the initial and final temperature also. Difference of here, difference of temperature, which can be denoted by what? dt. This is equal to what? T1 minus T2. Now this is equal to how much? 20 degrees Celsius minus 10 degrees Celsius, and this is equal to 10 degrees Celsius. Now we can use equation. We have very simple equation. Q equal to m into S into dt, and we are going to calculate Q, and m is given here 4 kilogram. If you want, you can write the unit also in the process, and specific heat capacity 460 joule per kg degree Celsius into difference of temperature dt is how much? 10 degrees Celsius. And this kilogram and this kilogram cancel, degree Celsius cancel, only joule is left. And when we multiply 4 with 460 and 10, then the result will be 18400. We can use calculator easily. Therefore the final result is what? Q equal to 18400 joule. Let's take another numerical, the similar numerical but not the same. Look at this. A pressure cooker has mass 4 kilogram and its temperature is 30 degrees Celsius. If the specific heat capacity of pressure cooker is 1000 joule per kg degree Celsius, what will be its final temperature when 80 kilojoule heat energy is supplied to it? Sometimes some of the students feel that numerical problem is difficult part of his study or her study. This is wrong. If we write the information given in the numerical problem, then the same numerical problem becomes very comfortable for you, and that's why let's write first what are the given in this numerical problem. First is mass is given. That's why I'm writing mass. M is equal to how much? 4 kilogram. And then what is given? And its temperature is 30 degrees Celsius. This is initial temperature. Initial temperature. Initial temperature can be denoted by T1. This is equal to 30 degrees Celsius. If the space heat capacity of the cooker is 1000 joule per space heat capacity, space heat capacity, which is denoted by S, is equal to how much? 1000 joule per kg degree Celsius. What will be the final temperature? But final temperature, this is the question, we'll write later. But before that, we have to write this: when 80 kilojoule heat energy is supplied to it. Heat energy or quantity of heat. Denoted by Q. This is equal to 80 kilojoule. But we have to use SI unit, or we will use joule unit. That's why 80 kilojoule can be converted into joule by multiplying it with 1000. This is equal to 8 having 4 zeros, 80,000 joule. Now, where the question now is turned to write question. Where the question, what will be its final temperature? Let's say final temperature is T2. This is the question. Now, how can we solve this numerical problem? There is only one equation which I used just before this also. We have Q equal to M into S into dt. And instead of dt, you can write another step also. Q equal to M into S into, what is dt? dt means difference of temperature, and final temperature is greater than initial temperature. That's why T2 minus T1 is dt, difference of temperature. Now we can take values. This much, this if you want, you can write units also, but if you feel it is a little difficult or it is confusing, that's why you can ignore the unit also. You can write unit in the final answer. That's why I'm not writing unit. Q equal to, what is the mass? 4 kg. And what is the value of space heat capacity? It is 1000 joule per kg degree Celsius. And what is the value of T2? We are going to find out. And what is T1? 30 degrees Celsius. Now next step, now it's the matter of calculator only. Now 80,000 is, this is equal to 4000 into T2 minus 30. Now if we take this 4000 in this side, then this is equal to T2 minus 30, 30, and here also 30. If cancel, then what happens? Or 80 minus becomes plus when it comes to left hand side. 80 divided by 4, it's better to cut it. 4 ones are 4 twos are, it becomes 20 only, not 80. 20 plus minus 30 is, if taken to left hand side, it will be plus. Minus 30 is becomes plus 30. This is equal to T2. Therefore T2 is equal to 50 degrees Celsius. Now we can write one final sentence for our answer, that is, therefore final temperature is 50 degrees Celsius. This way we can solve this type of numerical. Sometimes question may be like this also. Calculate the amount of heat required to heat 5 kilogram mercury from minus 50 degrees Celsius to minus 10 degrees Celsius. What is meaning? Minus 50 degrees Celsius is less temperature, but minus 10 degrees Celsius is more. That's why minus 50 to minus 10 degrees Celsius means this is more temperature, this is less temperature. Specific capacity of mercury is given this month. We have to find out the what? Amount of heat. That's why let's write first the given information. What is given? Mass is given. Mass denoted by m. This is equal to how much? 5 kilogram. And initial temperature and final. So this is initial, this is final. Initial temperature. Initial temperature T1 is equal to minus 50 degrees Celsius. Now final temperature T2 is equal to minus 10 degrees Celsius. Now specific heat capacity denoted by S is equal to 140 joule per kg degree Celsius. Now, what the question? Calculate the amount of heat. We can use H symbol also. What? Now I'm writing equation. We have H equal to m into S into dt. Now again I'm writing the same, but in place of dt I want to write T1 minus T2. Now let's take the value. S remains same. We have to find out S, and mass is 5 kilogram and specific capacity is 140 joule per kg degree Celsius. Now here we have a little confusion. We may have a little confusion because students think T1 is initial temperature, which is less. You have to think like this, and this is final temperature, which is more. That's why final minus initial is the difference of temperature. So I'm writing minus 10 degrees Celsius. In place of T1 I'm writing minus 10 degrees Celsius. This is final temperature. It will be better to have here final temperature is written as T2, then I want to correct this T2 minus T1. Okay, now final temperature 10 degrees Celsius minus initial temperature, how much it is? Minus 50 degrees Celsius. That is minus 50 degrees Celsius. It will be better to write this way. Okay, now what happens? Or S is equal to 5 kilogram into 140 joule per kg degree Celsius into, now minus 10 remains same, degree Celsius, minus minus plus, now 50 degrees Celsius. Now what happens in this expression? Or H, this is equal to 5 kg into 140 joule per kg degree Celsius into 50, which is positive, and 10, which is negative. 50 minus 10 becomes 40 degrees Celsius. Now this is our final calculation. Degree Celsius cancel. Or H is equal to 14 5 is 70 0 joule into again 40. Therefore H is equal to 28 having 1230 joule. Finally we can write one sentence for our answer. What is this? Here amount of heat is required, therefore required amount of heat is 28,000 joule. Okay, this much for today.